Hello, and welcome back to College Algebra. Today I'd like to explore applications of linear systems, aka word problems involving systems of equations. I have three examples for you, so let's go ahead and get started. Julie wants to make 10 pounds of chocolate peanut treats. Her cost per pound for peanuts is $8. Her cost per pound for chocolate is $16. Julie wants to make sure her cost per pound for her chocolate peanut treats is $10. How many pounds of chocolate and how many pounds of peanuts will she need? It's easy to get bogged down by word problems like this, but what you need to know is they're quite simple if you know the trick. The first trick I'm going to tell you is think about the physical situation that's going on. Physically, Julie's taking chocolate, she's taking peanuts, and she's making chocolate peanut treats. If we wanted to express that in terms of weight, we have an unknown amount of chocolate plus an unknown amount of peanuts equaling 10 pounds. I usually refer to this as the weight equation. It expresses what is physically happening. The next equation that we'll need to solve this, the rate equation. Notice that the rate on chocolate is $16 a pound, and the rate of peanuts is $8 a pound. We're going to mix these two things together to get a 10-pound mixture that costs $10 per pound. So 16C plus 8P equals 100. Now we have two equations, we have two variables, and we can solve this just like we solve any other system. I typically like solving systems through elimination. I will notice that if I multiply the top equation by -8, I can get my p's to cancel. So, -8 times c is -8c, -8 times p is -8p, and -8 times 10 is -80. Now I have a new system, and I can solve this system. I'll simply add these together, and I'll get that 8c is equal to 20. So c is equal to 20 over 8, or 5/2. Remember that c is the amount of pounds that we need of chocolate. And so we need 2.5 pounds of chocolate. Because we needed 10 pounds total, that means that I'm going to need 7.5 pounds of peanuts. Billy invests $50,000 into two interest-bearing accounts. One account gives 8% interest, the other gives 5% interest. After a year, Billy makes $3,500 in interest. How much did Billy invest into each account? Again, this problem may seem intimidating at first, but we just break it down. First, we ask ourselves, what is physically going on? Well, physically, Billy is going to the bank with a wad of cash, and he takes that wad of cash and adds it into two accounts. Account A and account B together equal $50,000. We have our quote-unquote weight equation there. Now let's make up a rate equation. Arbitrarily, I'll say that the A account gives 8% interest. So 0.08A plus 0.05B is going to equal the rate applied to $50,000, which is $3,500. Okay, I have a system. I've got two variables, two equations. I can solve this. As I've said before, I always use elimination. Well, not always, but almost always use elimination to solve these. So I will multiply this top line by negative 0.05. Substitution bothers me, but decimals do not, because I have a calculator to do all that heavy lifting for me. So negative 0.05 times A is negative 0.05A, times B is negative 0.05B, and times 50,000 is negative 2,500. I have a new system. I'll add these two lines together. When I do, I get that 0.03A is equal to 1,000. That means that A is equal to $33,333.33. I know that we have $50,000 total, so I just subtract $33,333.33 from $50,000, and I'll get that the money going into the other account is $16,666.67. Armando has an amount of 91% alcohol solution and an amount of 50% alcohol solution. However, he needs a 70% alcohol solution. How many ounces of each does he need to make 20 ounces of a 70% solution? So just like all the rest of the problems that we've done in this video, the first thing we want to do is come up with an equation to describe what is physically happening. Here, Armando is taking solution A, that's 91%. He's adding an amount of solution B, that is 50%. And he's getting 20 ounces of a 70% solution for it. So we have A plus B equals 20. That's our quote-unquote weight solution. Now we want to attach the rates. The rate of A is 91%. The rate of B is 50%. And the rate of the 20 ounces is going to be 70%. 0.7 times 20 is 14. I now have a system that I can solve. To be different, I'll solve this one with substitution. I examine the first equation and rearrange it so that B equals 20 minus A. Then I'll take this B and substitute it into the second equation. So 0.91A plus 0.5B, but B is now equal to 20 minus A, equals 14. 0.91A plus, let's see, half of 20 is 10, minus 0.5A. All I did was distribute that through, equals 14. (0.91A minus 0.5 gives us 0.41A. I'll also move that 10 over. That becomes a negative 10 on the other side, giving us 4. To isolate A, I divide 4 by 0.41, and I get that A is equal to 9.76 ounces. If we had 20 ounces total, and we subtract 9.76 ounces from that, we get that B is equal to 10.24 ounces. So, we'll need, of the 91% solution, 9.76 ounces, and of the 50% solution, 10.24 ounces. I hope you found that video helpful. If you'd like to see any videos on a certain topic or have a specific question answered, feel free to email me or contact me through my Google Voice number. Hope you all have a great day, and we'll see you next time.